Hello and welcome. Today, we're diving deep into a contentious topic, deep sea mining. Imagine vast, untapped mineral resources lying on the ocean floor. Cobalt, nickel, copper, critical for green technologies like electric car batteries and wind turbines. This allure is driving global interest, but it's a pursuit filled with economic uncertainties and potentially severe environmental consequences. Technologically, we're getting closer. Remotely operated vehicles, or ROVs, can explore and map the seabed. Specialized collectors, like giant vacuums, gather polymetallic nodules. Other tools cut and extract cobalt-rich crusts. Then, vertical transport systems, essentially giant pipes, would bring these minerals thousands of meters up to mining ships on the surface. But despite these advances, the economic viability is a huge question mark. We're talking extremely high upfront costs. Metal prices are volatile. As of early 2025, no commercial project has proven profitable. In fact, there's currently a surplus of key minerals like nickel and cobalt, driving prices down. For deep-sea mining to make economic sense, it would likely need to operate at an industrial scale, possibly over 500,000 tons of ore per year. Plus, new battery technologies are emerging that use less or no nickel and cobalt, which could further dent demand. Now, let's talk about the environment, because this is where the alarm bells are ringing loudest. Deep-sea ecosystems are among the least understood on Earth. They harbor unique, slow-growing species. Mining would directly destroy habitats. Organisms living on nodules or seamount crusts, like deep-sea corals, could take centuries to recover, if they ever do. Studies show that even decades after test mining, the seabed bears scars. A staggering 90% of species in some target zones might be new to science. Then there are the sediment plumes. Collecting minerals and discharging wastewater will stir up clouds of sediment that can spread, smothering marine life and clogging their feeding systems. We're still learning about how these plumes behave and how species will cope. Add to this noise and light pollution in previously dark, silent environments, potentially disrupting animal behavior, communication, and reproduction. Mining could also release toxic metals locked in the seabed, poisoning marine life. And let's not forget the deep ocean's role in carbon sequestration. Disturbing it could release stored carbon. This could even impact fisheries and coastal communities. A major hurdle is the lack of comprehensive baseline data. Many scientists argue we can't properly assess the environmental impact because we simply don't know enough. This has led to calls for a precautionary approach, even moratoria, until we have better science and effective management strategies. Regulating all this falls to the International Seabed Authority, or ISA. They're working on a mining code, aiming to finalize it by July 2025. But it's been tough. Member states are divided on environmental standards and how to share benefits. There's even pressure from potential applications for exploitation licenses before the code is fully adopted. So 2025 is shaping up to be a crucial year. The ISA has a new Secretary General, and some hope for a greater environmental focus. The debate is stark. Secure critical minerals for the green transition, or risk irreversible damage to fragile, largely unknown ecosystems. As of early 2025, 32 countries and many scientific bodies are calling for a pause. Others are eager to start. The path forward for deep-sea mining will hinge on technological progress, economic realities, our evolving understanding of the deep sea, and international negotiations. Transparency and science-based decisions will be absolutely critical.